Welcome to this tutorial about the GRIN material property. The GRIN material property can be used to simulate classical GRIN lenses or for tolerancing index inhomogeneities, or as well, for example, for thermal lensing in high power laser systems. And for this purpose, any lens material can be assigned a specific GRIN profile in the optical design editor. And to assign a specific GRIN profile to the singlet lens element, in our case here, we just open here this singlet lens, and there we can see here this material icon, and by clicking with the right mouse button on this material icon, we can see that here in the drop down menu we can select different GRIN profiles. Here, for example, the radial profile, the axial, spherical, Lüneburg, Rochester, or the 3D grid profile. We could do the same by clicking here on the construction tab, and here on the very right side we can also see the same GRIN profiles, which we could select as well here from the construction menu. In our example, we will add a radial GRIN profile to our material, and for that we click with the right mouse button, select here this radial profile, and now we need to insert the specifications that we got from our manufacturer. And now we can see here in the 3D view the curved propagation of the rays inside the GRIN media. And this whole GRIN system can of course be analyzed with the analysis plots that we got here in the analysis tab. Like all other parameters in the optical design editor, the GRIN parameters can of course be optimized by activating here this variable icon. The iconal equation, which needs to be solved to obtain the ray path through the GRIN media, is solved by an iterative algorithm based on the Runge-Ketta method, and the step size for each iteration can be set via this C-step parameter that is common to all GRIN material properties. A smaller step size increases the accuracy, but also requires longer computation times, and for that, the best way to find a good value for the step size is to start with a large value, so for example 5, and then just reduce the value step by step until the changes stay within an acceptable tolerance. There are two important things that you should know about the GRIN material property. The first important thing is about tolerancing, that I will show you here in the system that I've prepared. The GRIN profile is defined within the local coordinate system of the respective lens, and it is not assigned to the surface coordinate system. And this allows the axis of the GRIN profile to be defined independently of the surfaces, which is essential for realistic tolerancing. To show what I mean, I will switch between those three configuration states. So here on the top, the first configuration, in the middle the second, and here on the bottom it's the third configuration state. And here in the first configuration state, neither the surface nor the element is tilted. In the second configuration state, the first surface is tilted, but the element itself is not tilted, and therefore the GRIN profile is not tilted as well. When switching to the third configuration state, the whole element is tilted, and therefore the first surface and the GRIN profile is tilted. This means that the refraction at the first tilted surface is identical between configuration 2 and 3. However, since the GRIN profile axes differ in between the two configurations, a different path of the rays when propagating through the inhomogeneous media can be observed. For the second important thing, I've prepared as well a system. And what I wanted to show here is that the surfaces of the GRIN lens are not limited to a specific shape or face type. This means you can use any surface type, and therefore, for example, even use GRIN profiles on freeform lenses or diffractive optics. And this is important, for example, for simulating the index inhomogeneity of an aspheric lens here in our case. So this means you can use the GRIN profile in combination with any surface or form type that you can find here under the construction tab. If you are interested in how to define index inhomogeneities, for example for tolerance or stop analysis, you can watch the GRIN inhomogeneity tutorial. Thanks for watching.